Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So thank you. My name is Nick Willer, and like Scarlett introduced me, I work here at the Microsoft Research lab in the Sensors and Devices group, which is a group where we do a lot of hardware work, mostly looking at new devices, interactive devices, and new forms of interactive with technology, and enabling new forms of interaction through new devices, new sensors, and new systems. So the project that I'm going to be talking about today is called the Microsoft.NET Gadgeteer. And just if I sum it up in one sentence, it's .NET Gadgeteer is a toolkit. It's a collection of different tools that make it very easy to go from having an idea about a device, a new gadget that you want to build but doesn't exist yet, to shortly after holding that device in your hand and using it like a real device in a way that feels and operates very, very close to a finished product, a very high fidelity prototype, if you will. The sort of the driving goals when designing this was to make a toolkit that allows you to build gadgets. And it should have a low threshold. It should be something that's really easy to do. Building a simple gadget should be really easy to do, but also it should have a high ceiling. Once you know how to use this, it shouldn't be a stepping stone to moving into something else. This toolkit, this platform should grow with you and allow you to build really sophisticated devices as your abilities and programming skills grow. So just as much for beginners as for advanced users. So there's really three key components sort of underlying the .NET Gadgeteer platform. And this talk will focus on with sort of structure by talking about each in turn, and then bring them all together at the end and showing you how these things come together to allow you to build gadgets really easily. So first is modular hardware. The second is object-oriented programming. And the third is digital design and fabrication. So before we get into it, just a little bit of history, a little bit of context about why we did this project. And we originally built Gadgeteer as a tool for ourselves in the lab to make it faster and easier to build prototypes. Like I mentioned, we build devices all the time just to see if it's a good idea or not, to prove of concept. We found that we were reinventing the wheel a lot. So we thought, let's make it easier for ourselves. Let's build some tools that allow us to make these things really easily. And that was the start of it. But since then, that was about 2 years ago, and we've been developing it further. And we've seen that it might be useful outside of the lab, outside just for us, for other researchers building that have to be devices and people at universities and in companies where they have to build proof of concepts and prototypes. But also, and a little bit to our surprise, a lot of people have come up to us and said, this would be really great as a way to get people excited about technology, about building devices, and about learning to program. And as a result, we're sort of investigating that a little bit more. This might be an interesting educational tool as well. I'll talk a little bit more about that at the end. So what we're doing is at the moment, with the help of colleagues from all across Microsoft, including Scarlett and the Microsoft Research Connections, we're working very hard to get Gadgeteer out of the lab and into the hands of other people. And I'll talk about exactly how we're doing that at the end. So I'll go back to talking about the modular hardware. And really at the core of the Gadgeteer toolkit is this set of modular hardware that can be easily plugged together. It's little hardware modules individual circuits that can just connect via these like little ribbon cables without any need to solder. You just plug things together to make your device. And the best way to explain it is just to like show you this little video of me quickly putting together a digital camera. So the module in the center is the main board, is the main processor unit. I've connected to it an SD card slot, a USB interface for power, and a little display. This is a little OLED display, 128 by 128 pixels. This is a small digital camera module that I can clip onto it. And you can see everything just uses the same cables. Cables are of different length, but they all use the same sockets. And this one is, it's really simple, it's just a push button. I'm adding an SD card into the SD card slot. And now I'm plugging into my PC, which is off screen. And I've already written some code. It took me maybe about 10 minutes, but the code, what it does is, it's very simple. When I press the button, I ask the camera to take a picture, then put it on the display and save it on the SD card. Here we go. So this whole video was speeded up, but I'm glossing over the programming part. Yes?
So you produce the hardware pieces as well?
Yes. I'm glossing over the software part, but I'll get more into it in a little bit. So yeah, these are the modules that we produced ourselves. A lot of them we've just adapted. They're existing electronic components that we've just adapted to work with the Gadgeteer platform. Some of them we built from scratch.
Can they also be combined with normal hardware components?
What do you mean by normal hardware?
I don't know, for example, when you're building a robot, it's kind of, you have like lots of different small plates. Can you connect them? Can you, like, for example, take your Gadgeteer stuff and combine it with existing robot?
Yeah, I think I know what you mean. Yeah. So I can show you, and I can show you at the end as well a little bit more in detail how you can do that. But that's really important. It's the whole idea is that you're not just bound. We provide a lot of initial building blocks, but it's not a finite set. So you can always interface with other existing things. And we also provide a mechanism for making new modules and taking those existing things and adapting them so they work as a one-off. So this is just like an overview of some of the modules we have. The module set has grown quite a lot since then. That's the main board. That's the main processing unit. It uses an ARM7 microcontroller at the moment. It could also use an ARM9 quite easily, and probably will in the future. That just contains the processor and some memory. We have a whole bunch of user interface modules. These are USB hosts, allows you to plug in a keyboard or a mouse, for example. Push buttons, these multicolor LEDs, a little display that you saw, rotary encoders, a little joystick. Not shown here is we have bigger screens with a touchscreen interface. There's a bunch of sensor modules, temperature and humidity, RGB sensor. It measures the color of the ambient light. An ultrasonic ranger to give you distance, motion, accelerometer. These are the multimedia, what we call multimedia modules. We have an audio module that lets you record sound and also play back MP3 or WAV or OGG file formats. You plug in some speakers and some headphones onto it. The little camera that you saw in the video, it's just a stills camera at the moment. Communication networking, so we have like Wi-Fi Ethernet. You can easily plug this in to a network. Also, we have a Zigbee module that allows you to create mesh networks for local low power communication. Storage, so there's some memory on the device. 16 megabytes is actually a lot for your program logic. But if you want to store images or big files or log large amounts of data, you might want to add an SD card, or in the USB interface, you can plug in a little storage device, and that works. Actuators, we have a motor and servo control board, which is pretty cool for building things like robots, and also relays that allow you to interface with high voltage things, appliances and things in the home, and control fans and heating systems. Various ways to power these things. You can plug it via USB, like you saw in the video. You can even the power supply is modular, which is an interesting design choice that that has turned out to be really good because it means that you can swap out the USB power supply and power it from DC by adding a wall wart on the wall, or adding a rechargeable battery, and you can make battery-powered devices. And then I guess this gets back to your question about how to interface with all these things. So we have a number of modules that simply let you connect arbitrary electronics to here really easily. So analog things, digital things, and then the breakout simply exposes all the pins that are on each one of the sockets and let you connect it to your module. So part of what we have with Gadgeteer is it's a very open specification about how these sockets connect. So we have this pin mapping table, and all we're saying is if you're making a module that needs the UART interface, simply put the pins in these positions, and then you'll be sure that it's compatible with any Gadgeteer mainboard. And then this is an interesting scheme. I won't go into it too much, but it lets you, one socket can support multiple protocols, and you can combine them up. But it's very open. So if you know about electronics, this should be quite straightforward to know how to plug things into Gadgeteer. We also have a bunch of module design guidelines, templates, and guides for how to make your own modules. So, and that's really, I'll reiterate that because that's really important. This is not a finite set that I show you there. It's growing all the time. And the idea is that, you know, if there's a module that doesn't exist that you want to use, you can start with a breakout module, just connecting your mainboard to a breadboard, prototyping the circuit or the sensor, and if that works, there's an easy sort of or a clear pathway to sort of then sort of crystallizing that as a Gadgeteer module and a design that then you can publish online or sell or whatever and give to other people, and then they can really use. Anyway, so those are the design guidelines. Again, I think at the end, I'll spend a little bit of time here. I'll try and finish the talk a bit early. And then if you want to come and actually look at the hardware, it's the best way to get a sense of how it works and what you can do with it. And I can give you a little bit more detail about how you make modules if that's something that you're interested in. But now I'll jump to how you program these things. So it's all very well and good to be able to plug these things very quickly. But programming it is a key thing, making it do what you want. So we have we've developed a number of software development libraries, an SDK, there's the Gadgeteer SDK, that builds on top of a Microsoft technology, which is called the Microsoft.NET Microframework. So I don't know if you're familiar with I guess if you're all here, you must be somewhat familiar with the .NET technologies. And you know, .NET is the set of abstractions, the set of libraries that you use to program your PC. Then there's like the .NET Compact framework, which is smaller and it's targeted more at embedded devices, like things with like PDAs and points of sale and those kind of more embedded devices. This is the micro framework, which is even smaller. It's the absolute minimal set of .NET, the most minimal .NET implementation, and it has a really small footprint. It's like it's like 100K or 200K. So it can fit in small microcontrollers that you wouldn't normally think would fit. You'd be able to run the common language runtime on. So this is the .NET Microframework is it's an open source project that came out of Microsoft really, and it's been ported to a number of devices. Like these are two devices that already use the .NET Microframework, the NetDuino made by Sacred Light and this FES board. They already use the .NET Microframework, and then you can. And what it lets you do is write software in C#, use Visual Studio as your integrated development environment, and then. But on top of that, we've added the Gadgeteer SDK, which. So this is the new the .NET Microframework. You have all the sort of standard layers of abstraction. We add on top of that a bunch of libraries and a bunch of sort of helper tools that let you do certain things easier. For example, use the modules that are in the kit. You don't have to re-implement an interface for the screen. You already have a software object that represents the screen, and that software object contains all the methods for drawing display. For example, turning an LED on, you'd instantiate a new LED object, and then you'd say LED.on or LED.setColor. It's at that level of abstraction. equally is display dot draw circle, you know, at that kind of level. If there's some at the end, I'll do a live coding demo because it's quite nice to see how Visual Studio helps out. You know, we try to integrate really well with the Visual Studio development features. These things like code suggestions. There's this feature called Intellisense that sort of prompts you at various points during the code. So, do you mean this? Do you mean? And lets you select parameters and properties and methods from drop-down boxes. It's all event-based. It's really, you can do live debugging of these devices. So you plug it into your PC, you write your code, you deploy it, and the code's running on the device. But it's actually, you know, sort of objects are persisting in memory here. So it's very easy to do that live debugging in Visual Studio and add breakpoints and step through your code. It feels like you're programming a PC, not this little embedded device. We have a bunch of templates for different applications. So if you want to do a graphics application, you know, you start from the Gadgeteer graphics template. Or if you want to do a simpler sensor-based application, you start with a blank template and so on. On top of all those the libraries, we've also been developing this concept of the Gadgeteer Cloud Portal for Web of Things applications. So a lot of the kind of things that people want to build with Gadgeteer devices, since they have such good networking capabilities and you have a full networking stacks, are getting them to talk to each other and to support that, we've developed this Gadgeteer Cloud Portal, which basically with very few lines of code, maybe with 3 lines of code, let's do something like share a picture that you've taken with your Gadgeteer device and put it in this Cloud Portal, which is, it's kind of like a whiteboard, a tuple space where you can put sort of data and key value pairs, and you say, okay, I've taken a picture, this device has taken a picture, I put it out there, and I can pull it off by another device, or with a Windows PC, or a Windows 7 phone. So we have libraries for all of these things that let you do this release. It's just like, literally, I think it's 3 lines of code to take a bit of data, or a picture, or an image, or a bit of sound, and transfer it between devices. It also, the Cloud Portal lets you integrate with other web services like Twitter. So for example, if you want your device to make a Twitter post whenever it detects something, you can make a home alarm that you get a tweet when someone walks into your room or something like that. Again, that's really simple. It's just a few lines of code. So, wow, I'm doing super well. Then this comes to the final part, is the digital design and fabrication. So when you build prototypes with Gadgeteer, they look a bit like this. I'm going to do one. So I'm going to, you saw the digital camera at the beginning. And you know, they're kind of robust because there's no soldering involved. So things tend to stay together and don't fall apart. But they're not very pretty to look at. If I'm honest. So for example, you get this spider effect, you know, where you have like everything dangling, and this is fine. Like if it's in your desk, it's absolutely fine. You know, it proves the concept. You can debug, and it's really nice to have it so open because you can switch things around and try different things. But if I build a digital camera like this, I'm not going to want to put it in my pocket and use it. I'm not going to want to give it to someone else to use it, and that's really quite important. So we've been thinking about how to move from this to something that, you know, looks more like a product, something like this. And when we've run a couple of Gadgeteer versions, one thing that people love to do is build little enclosures for these things, and do it by cardboard is probably the easiest way. There's like hundreds of materials, but it's a very common sight. People taking cardboard, scoring it, punching holes in it, decorating it, and this is amazing. People built this in like 2 hours. It looks really cute. It's like a little bear, cuddly toy. But when you approach it, it has a distance sensor on the nose, and when you approach it, it detects that, and the eyes go red, and the the eyebrows sort of go like this, and it's like it growls, and it's really quite cool. So that's great, and that's fine as a first prototype. You can do it very quickly. It's also fine if you're only making one. But if you want something a bit more polished, more robust, or something that you're going to want to make a batch of, 10, 50 of, then I think you probably want a different way of making things, not making it by carpet and by hand. So I'm quite excited by digital design and rapid manufacturing technologies, so 3D printing and or digital fabrication, all the buzzwords that go with it. Sort of the basic idea, I guess most people are familiar with this concept, is you draw a 3D CAD model on your screen, you design a 3D object on your screen, you specify its dimensions and its shape, and you feed it to a machine, a 3D printer or a rapid manufacturing machine, that will then take the digital design and render it out of plastic. So it'll build it up layer by layer into a solid model. So you put in this model, and then what you get out of it, it's a solid object. Here's a little video of one of the smaller 3D printers doing this job, if you haven't seen one before.
You have a bath to the top.
I didn't realize I had some. So you see, this is just printing out. It's actually a more refined version of the little bear thing that you saw earlier. And it's doing it layer by layer. These are sort of the openings for the eyes. And it's just putting up layers upon layer of plastic and sort of slowly building up a 3D object. Yes? Yes. So yeah. There's lots of. I mean, some of the high-end machines are amazing. You can do not just colors but different materials. So you can go from hard plastic, like ABS-type plastic, to rubber. And you can mix and match these materials. They're pretty cool. So, but this one that we have here, this one's like I think a $12,000 machine. So it only does one color at a time. You can switch the colors. But it can make objects about as big as that. They're really strong and robust. And oh, sorry, yeah.
It's creating only the cover, or also the integrated objects like chips or buttons.
Just the plastic at the moment. But that's why we got so excited when, parts of when we've got our 3D printer in the lab, and we saw this thing just printing out plastic and thinking, oh my God, you want to print out active objects, right? You want to print out computers. You want to print like interactive devices. So actually, Gadgeteer, it seems to be, let's say in 20 years' time, you'll be able to print a lot of the components as part of the printing process. There's a lot of advances in printable electronics at the moment. But at the moment, it feels like the combination of modular hardware and the ability to print arbitrary shapes is really powerful. So you just print this, and then you just snap in your electronics. And that's exactly what we're trying to make easy at the moment. Yeah?
Can I ask another question? So we've been talking about Python program. How do you deploy it? Can you run the application on the hardware?
Yes, I'll get back to that at the end, if you don't mind. Yeah. I think we'll have time to do a live demo of how you write the code. I just wanted to finish because I tend to get really sidetracked and talk about 3D printers because I get so excited. But part of the reason that I'm excited about it is because they're falling in price a lot. These are machines that you used to see in sort of high-end architecture studios 5 years ago. But now you can get a MakerBot, which you can put together for about $1,000. And it'll do a reasonable job of printing out your 3D objects. So anyway, we think there'll be a lot more of these things in the near future. And even in between, if you don't have a 3D printer, there's a bunch of online printing services where you can make your design, you upload it to a website, and then you get back a couple of days later a solid object. And people do amazing stuff. And you can specify your material, the color. You can print in metal, we've got back some jewelry which is gold-plated, for example. I think you can make things out of ceramics. It's really quite cool. So anyway, that's a little detour to tell you what I'm excited about. 3D printer. But we're very interested in using these kind of technologies to allow you to give shape to Gadgeteer devices, right? To turn that into an object that you want to use. And what we have at the moment, it's a step in the direction. It's nothing super revolutionary, but it's going to be quite excited about what we'll be able to do in the next couple of years. So what we've done is, as a first step, is we've taken an existing CAD tool, which is called SolidWorks, which is sort of one of the industry standards for designing 3D objects and fitting into 3D printers, and we've extended it with the Gadgeteer Toolkit. Unfortunately, I can't give you a live demo because I'm not on my machine, but I'll just run through the slides. So what this tool, so most of this is SolidWorks except this region here. That's the Gadgeteer Toolkit. So it's a little panel the Gadgeteer add-in that clips into the program. And what it allows you to do is, for example, create a box based on a template. So even if you've never done any CAD design, even just making a box is a bit challenging. You have to figure out how to use the software and think about in 3D and 2D projection into 3D. But we want to make it really easy. So we have a number of different templates where I say, I want a box, and I want my style of the box to be either, this is one style, the jigsaw. We have another style. It looks a bit like this. It's a more standard box, sort of five sides and a lid. And then you give it its dimensions. So you can say, this is how thick I want the walls, this is how tall, how wide. And you just type these numbers into the panel. And then it makes the box for you. The next step then is you say, I want to add the Gadgeteer modules that I'm using in my project. So you click a button, and it gives you here a list of all the different modules that I have in my toolkit. And you can load them in. You can load up very accurate 3D representations of the models. So for example, the one at the top is the mainboard, and you can see it's really quite accurate, down to every single connector is exactly represented in the right place. And I can preload them, and I bring them into my virtual object. Then I can position them inside the object. So in this case, I've opened up the box and my screen, and I've put the Ethernet connector inside here. You see what I mean? I use one of the features that we've developed called auto mounting. So you say, mount this, I want this Ethernet connector to be suspended here. So it'll automatically generate some geometry. It'll generate some little plastic pillars here that will hold the object at that spot. And that's halfway useful.
Those plastic pillars are going to be printed, or it's part that you have to mount on the plastic?
No, they'll be printed. So everything you see here, except the modules themselves, will be printed. Yeah. Actually, I might. Yeah, let's pass this around to give you an idea. So this was 3D printed and designed and made using the CAD tool. And you can see the little pillars. So, and there's different ways of mounting it. Like you can mount it with pillars, or we have some predefined ways of mounting it, so little latches and little things. But this is only partway useful because now we've got an Ethernet connector inside the box and no way to get into it. So another of the features, you can click again on the Ethernet connection and say, I want to make a hole for it. So it'll automatically, it knows that this is a connector and that this is the bit that you want to expose to the outside world. So it'll project a cutout. It'll make a cutout on the side of the case that fits exactly the connector. And if you have a look as the case gets passed around, it's actually quite neat how everything fits exactly in place. And yeah, it can generate its openings. If it was a display, for example, it would know to generate an opening just for the display area, not for the whole module, but just for the active bit where the screen is. So just to finish, I wanted to give you an idea of how all these things come together. So it's quite a while ago, maybe relatively early on in the project, we set ourselves a challenge to say, if if we were able to do what we set out to do. And so we said, can we in 24 hours go from just nothing to having a very high fidelity prototype of a handheld video game, a little handheld Tetris playing machine, a bit like a basic Game Boy. So we started, the hardware configuration took about 5 minutes. We took a USB connector for power. We didn't have a battery then at that point, so it had to be powered by USB. A little joystick, the 4-way switch to move the little Tetris puzzle piece around, and the knob to rotate the pieces, and the little display that you saw earlier. The software development took about 5 hours, which is not bad. I mean, if you consider how complicated it is, especially a graphics application on an embedded device, it can be quite complicated. But this is just to give you an idea of the level of abstraction that you're dealing with. You're talking about points and objects and things, like squares. You don't have to draw everything pixel by pixel. You work at a much higher level of abstraction. If you're familiar with the Windows Presentation Foundation with WPF, there's a subset of it that runs on the Gadgeteer. So actually doing graphics application is quite easy. This is the enclosure design using the tool. I'm not using one of the box templates. I actually did the whole design for the enclosure from scratch. I'm still using all the tools that allow me to mount things in place, but I didn't start with a box. So that's why it took longer. But still, 3 hours is quite good, especially in the knowledge that once this comes out, it's going to fit properly. You're not doing it by hand because it's all based on these very accurate models. And I know that I'm not going to have made a mistake measuring something or something is too tight or too loose. What took the longest was waiting for the 3D printer to finish. So we're actually programming while this was happening, but the 3D printer was off. This is the output of the 3D printer. It comes out in a tray, and you sort of prise the plastic pieces off, and you have to give them a wash to remove any support material. And this, just for illustration, the board was added, but it didn't get added by the machine. This is all done in hand. But that doesn't take that long. It took about 30 minutes to put everything together. There's lots of little screws and to screw everything in place. All the boards have these little standardized mounting holes, though, so that makes it really easy. You just have one type of little screw and one type of screwdriver, and everything sort of clips together. And that's it. And sort of considerably less than 24 hours later, we had sort of a fully working device that operates and looks and feels almost like a finished product. You can tell it's 3D printed, but you could spend a couple more hours on it and sand it and paint it and finish it really nicely, and you wouldn't know it's a prototype. Yeah, we should program that you always get the right piece. Okay, so anyway, that's all a Gadgeteer, and that's kind of, I hope I give you a good sense of how all these bits come together and how it's lots of separate parts where we're really thinking about as one toolkit. And we think that all these bits are important to let you do what you need to do. But as I mentioned at the beginning of the talk, what we're focusing now, and the last year really has moved from developing this thing in the lab to trying to get it out into the hands of other people. So the best way that we found to do this was to make Gadgeteer an open source project. Because this allows us to put it in the public domain, and it allows other people outside Microsoft to get involved in its development. Sometimes there's a perception that Microsoft sort of might throw some projects that it's done with over the wall for other people to develop, but that's not the case with Gadgeteer. We're still very invested, and we're in Gadgeteer, and we're actively working to develop it, and we have very concrete plans of how to move it forward in the future. But the reason we're putting it open source and it's under the Apache 2.0 license on CodePlux is really to allow other people to make it. Most importantly, people to make new modules, but also to make and sell them and make a business out of Gadgeteer. So that the sort of the top link is for the developer link. It has all the design guidelines and all the software. We're still populating it with all the documents. And then there's a community site, which is still in development, which is more for end users of Gadgeteer, the people that would like to buy it and use it. So we're working, just by putting something into open source doesn't mean that all of a sudden people start picking it up and start using it. So we're working with a number of different hardware manufacturing companies that are already in the business of making prototyping electronics and selling it, and have the distribution channels and the expertise and the manufacturing facilities. So we're working with them to have initial availability of kits. So they're making very Gadgeteer components. So some companies are making mainboards, and other companies are making modules. And the idea is that all these things will interoperate, and you'll be able to just look online. On our website, on netmf.com/Gadgeteer, there'll be a list of all the different modules and all the people that are selling it, and links to all the various web shops. End of July seems really close. But yeah, that's still, I think that's still the plan. We want to have initial kits, maybe not like thousands, but there'll be in the hundreds kits available. The basic kit, it's going to look a little bit different from what you'll see here. It doesn't have everything in there, but it'll have some really nice pieces. Again, because we're not selling it, we don't have a full control about how much it's going to be, but we expect a kit will be about $250. Which is quite a good price considering all the stuff that you get. So you get the main board. I think you'll get a display. It's not the little display, but a bigger display with a touch screen, things like a camera, a Wi-Fi connection, Ethernet connection, a bunch of buttons, LEDs, cables, etc., etc. So when you actually total it up and look at the bill of materials, it's not a lot, and it's kind of like a Lego Mindstorms kit kind of type of cost. And as I say, more modules will be available later in the year. Yes, so if you're interested in using .NET Gadgeteer, the best thing to do is to write to gadgeteer@microsoft.com and check the website. And yeah, if you have any ideas about a specific project that you would like to do, that you think this would be really good for, or you want to get involved in testing it as early as possible, or something like that, please get in touch, and we can talk. Yes, thank you. Oh, yes, questions.
So about the deployment, how do we deploy the application to the device?
Okay, if you want, I can show you in a few minutes. But basically, you write your code in C# Visual Studio. And then the default way is you plug your device via USB here, and then you just hit F5, compile. So it'll compile the code, it'll download it to the device, and then if the device detects that you're running a debugging session, it'll set up a debugging link. So it's executing here, and it'll just run normally, but you can add breakpoints to your code, or watches, or traces. And then you can step through everything. The moment you unplug it from the device, it'll reboot and it'll just start operating in standalone mode. You can also deploy via serial line if you that way inclined, or via TCP/IP. But it's just slower. So you can have a device which is remote, and you can reprogram it and do live debugging and stuff. Yeah.
Can you have devices while it's working?
No. No, it's not recommended. That's not part.
Question, say, if I have some custom device that has a USB interface, so how hard is to write, say, a driver for it?
That's a good question. It's possible. I haven't done it myself, but I've known people who have done it, and you can still do it from managed code. There's also a mechanism for writing a low-level driver in C if performance is really critical, and then loading it. There's a kind of like an interrupt mechanism, but then you're compiling your driver for a particular processor, right? So it's not as portable as if you do it in managed code.
Who has the intellectual rights on the gadgets which are made with this Gadgeteer? If I, for example, try to make a new logical scheme that which could be usable in manufacturing or something else, and try to go to have an invention patent.
Yeah. That's fine. So the software is all Apache 2.0, so there's no obligation of you to can use it as you will. It's not a viral license. And all the hardware designs are just Creative Commons. So I think not even by attribution. You can just use it and reuse it. That's extremely important, yeah.
Other questions? Yeah, over there.
Does this Gadgeteer device require connection for getting power, or it can work from battery?
It can run on battery. So one of the modules that we have is a battery module. So you can.
And batteries supply enough power for it to run for several hours, or?
Yeah. Well, it depends on what you have on the device, right? It's let's say to drive something. I guess the thing that would consume the most power would be the backlight on the LCD, and with the mainboard and all these things, with one of the 2 amp battery packs, I don't know, 8 hours, 10 hours would probably run. No problem. So it's not. We haven't powered optimized. That's one thing we haven't done. So you probably don't want to do a wireless sensor network that operates in the wild for a year, right? But for doing consumer devices kind of things, things that you might expect someone to recharge once a day, yeah, it's suitable.
Question here first.
If I want to deploy the application on the custom board, do I need to actually deploy the whole .NET micro on that? I need to compile that with the micro on that particular processor.
That's right. So there's a porting kit that, you're talking one level down in terms of abstraction already. But so the Microsoft provides a porting kit, which has, I think it uses an ARM7 or an ARM9 as its reference design. People have ported it to all different types of things, but yeah, it's not one day's work to port the .NET Micro over.
I believe that actually Visual Studio doesn't compile for any architecture.
No. I think it's GCC code, so yeah. And and I know people have done it with the ARM toolchain. It's pretty straightforward with the Kyle program runs.
Is the underlying OS, and the underlying framework, is it multi-threaded, multi-process?
Well, they're single-core processors. You have concepts of threads, so you can spin off new threads. Huh?
Is it preemptive?
No, it's not preemptive. It's quite simplistic, but if in terms of application, it makes it just easy to have multiple things executing in parallel. You have some thread management, you have a garbage collector, and you have some control about how these things execute. Yeah.
Question: suppose I want to get frame buffer access to the display. Will I do that?
That depends on how much whoever's done that port, how much they choose to export by default. So most ports allow some mechanism to read and write to the registers directly if you want to do that. Yeah.
Right, so perhaps you can take the more specific questions over lunch, and if you want to show something.
Yeah. Is this a good place to set up, you think? I could do it outside or.
Yeah. Right. Okay. So Nick will be there over lunch and present Gadgeteer. If you want to have a look at the hardware or to see how the programming environment works, to come back over lunch. So it's about 10 minutes early now, but I suggest you.
I'll go and set up.
Yeah. Set it up outside in the reception area.
Good. Thank you.